In this video, we're going to discuss another example using the binomial probability distribution function. So let's go ahead and read this example. A couple has 3 children. What's the probability that exactly 2 children are girls? Assume that the probability of having a girl is 0.49. The probability of having a boy is 0.51. All right. So first, we need to be able to recognize that this is a problem where we are going to want to deploy the use of the binomial probability distribution. Right. So how do we recognize that? Well, first we need to recognize that there's two possible outcomes. Either you have a success or a failure, right? So a girl, in this case, a girl or a boy. So there are two possible choices. So that, remember, binomial starts with the term bi. So there's two possible outcomes, a girl or a boy. So that meets, this problem meets that criteria. Second thing you need to think about is, are the trials independent? Okay, so in this case, a trial is just like having a child. So is each child independent of the other? And yes, it's certainly that the case that the gender of the first child has no influence on the gender of the second or the third. All right. And one more thing you want to think about is, are we trying to find the probability that there's exactly x successes out of n trials? And yes, that's also the case. We're trying to find the probability that there are 2 successes out of a set number of 3 children. All right, so once you've determined that this is a binomial distribution related problem, go ahead and look up what's the binomial distribution function. Let's go ahead and write this down. Equals n factorial n minus x factorial p to the x and q to the n minus x. All right, so for our question, the random variable x is the number of girls out of 3 children. Right? So the number of successes, in this case, girls is a success, out of n trials, so 3 children. Okay. The value of n is 3. Right? There's 3 set number of children. The value of p, the probability of having a girl, remember p is the probability of success, so girl's success here, so that would be p is 0.49, and q then would be 1 minus p, 1 minus 0.49, which is 0.51. Right, so now let's go ahead and calculate this. What we're trying to calculate is the probability that x equals, probability that the random variable equals 2, right? In the question, we're asked to find what's the probability that 2 children are girls. Okay, so let's go ahead and plug everything in. So n is 3, n minus x, so 3 minus 2. X is 2, and then p, so 0.49 to the power of x, and 0.51 to the power of n minus x. Okay. One thing I want to point out, in the previous video we discussed the binomial distribution table. Okay. If we go to this table, all right, so we know that our n is 3 and our x is 2, but if we start looking in the table for the probability, we'll notice that p equal to 0.49 is not an option on this table. Okay, look at that top column, right? You don't see p equal to 0.49 as an option. So using this table is not going to work out for us. In this problem. So this table is very helpful for other problems, it's just not going to be helpful for this problem. All right, so I'm going to have to actually calculate this this function here, okay? So 3 factorial is 3 times 2 times 1. 3 minus 2 is 1, so 1 factorial is just 1. And then 2 factorial is 2 times 1, times 0.49 squared, times 0.51. 3 minus 1 is just 1, so to the first power. Okay, so 3 times 2, oh, actually there's some cancellation here. These cancel, right? So 3 divided by 1, which is just 3. Okay, so the number of ways you can have 2 girls out of 3 children is 3, right? That's what this front number represents, the number of combinations that you can have, 2 successes out of 3 trials. All right, so now I just need to calculate this. So let's just pull up our calculator. Let's clear it out. 3 times 0.49 squared times 0.51. Okay, so our answer is 0.367. Right? So 0.367. All right. This is really interesting, actually. So this means that out of all the children, or out of all the families that have 3 children, 36.7 of them have 2 girls, right? That's super cool. That's pretty interesting. So out of all the families that have 3 children, 36.7% of those families have exactly 2 girls.